Right then, today we'll look at similarity, which goes hand in hand with congruency. You remember from yesterday that congruency means that two shapes are congruent. They are exactly the same shape and size. They could be reflected, they could be rotated, they could be translated, but not enlarged. Two shapes are similar if one is an enlargement of the other. Two shapes are similar if all the angles are the same, but the sides are all in the same proportion. Okay, so for instance, two triangles, if all the angles are the same in two triangles, then one is an enlargement of the other. They are similar. So knowing that all three angles are the same is enough to know they're similar. If we knew that the sides were 2, 3, and 4, and 4, 6, and 8, if we knew that every side in the second triangle was double the one in the first triangle, then the two triangles are similar. One is an enlargement of the other. Now with triangles, not the true of rectangles, but all today's work is going to be about triangles. In rectangles, knowing that there are 4 right angles doesn't tell us anything about whether the sides are in the same proportion. There's two very rough drawn rectangles. So these rules are only true for triangles, okay, alone. And then if any two sides are proportional, so we've got 1 to 3, and then 2 to 6 is also the ratio 1 to 3. So both those pairs are in the ratio 1 to 3, and the angle between them is the same. We will find that the two triangles are similar. What does that mean? It means this side and this side will be in the ratio 1 to 3. It will mean that this angle and this angle are the same. It will mean that this angle and this angle are the same. In the same way that in the triangle above, because all the sides are in the same proportion, they will be equal, they will be equal, and the third angle will be equal. Okay, right, how does that manifest? Right, in a question it looks like this. If we are told that two shapes are similar, so we're actually told in this question, can we find that side there? If they are similar, all the pairs of sides are in the same ratio. And if we're assuming that this 8 and 12 go together, then we can work out the ratio, the scale factor between the two triangles. 12 divided by 8 is 1.5. We can use the 1.5 to multiply the 5 to get what x is. Okay, so this bit here is the crucial bit, is finding the scale factor. So in this second question, again, if we're told they're similar, that's what we're told in the question. It's not necessarily true of rectangles, but in this case we're told it is. Then what have we got? We've got the 17 and the 11 to tell us the scale factor. If we want to go from 17 to 11, we can multiply by 11/17. If we want to go from 40 to the x, we can multiply by 11/17. Or we can work out the scale factor, 11 divided by 17, and simply multiply the 40 by it. 440 over 17, and we'd usually turn that into an answer that matches the format of the question, and that's 25.9. Just checking that the x is smaller than the 40. That's a good way of checking you've got the ratio the right way around, to check if it's the right sort of size. We could embed the shapes one inside the other. So in this case, we're told BCD is similar to ACE. So BCD is similar to ACE. Okay, that's the important thing. Then we could draw the two triangles and decide which sides to put together to get the scale factor. Okay, before we do that though, let's look at why is BCD similar to ACE. The key to it is these symbols here. Two triangles are similar. There are three different criteria. One of them is that we've got angle C is common. So we could write angle C is common. We know that this angle is the same as this angle if the lines are parallel. We know that this angle is the same as this angle because those two angles are corresponding. And if two angles are the same in a pair of triangles, then the third is. So they're similar because we can prove the angles are the same. Let's go back to the question. Draw the two triangles out. The corresponding sides are 4 goes with the 10. And we're looking to find BD. We're looking to find this one here. So pretend we haven't put the answer in yet. So 4 over 10 is the ratio of the sides. BD goes with 7.5. BD and 7.5 go together in the same way that 4 and 10 go together. If you bring the 7.5 up to multiply by it, you get that sum. You get this sum here, which gives us that BD is 3. So a good way of doing it is form this equation here by pairing up the relevant sides, okay? Form that equation. So in this one here, AE and BC are parallel. So this one's parallel to this one. Explain why the triangles are similar. So alternate angles are equal. Alternate angles. Where are the alternate angles on the diagram? We've got two parallel lines. That angle is alternate to this one. This angle is alternate to this one, okay? Which is what we've set up there. And then finally, at the angles either side here, so let's draw those in. Angle A to D to E and angle C to B, D to B are, so we should have put that there, those two angles there are the vertically opposite ones. They're the same. All three angles are the same. Therefore, the triangles are similar. Okay. Now, how have we done this next bit? The sides that correspond, the sides that go together, the 2 goes with the 6. Okay. 2 goes with 6. The scale factor is 3. 2 times 3 is 6. So if we want to find, and let's just work out which way the triangles are arranged, remember this time that the 2 yellow angles go together. So the side that corresponds to this one is CD. And the side that, oh, that's all we want to find, calculate. And the side that goes with this one is ED, okay? So a small triangle is a third the size of the big one. The big one's 3 times the size of the small one. So E to D is a third of 12, or 4 times 3 is 12. And C to D is 3 lots of the 3, 9. Okay? On this one here, the 2 triangles are similar. Notice that that angle is marked the same as that one, and this one is the same as this one. So in this case, the sides that go together, 4.5 goes with the y, x goes with the 9. Okay, so the scale factor is going to be 6 over 8 3/4, or if you're working from small to big, it'd be 8 over 6 4/3. To get from 8 to 6, you multiply by 3/4. Where has that come from? It's 6 divided by 8. So to go from the 9 to the x, you multiply by 3/4. 9 times 3/4, 6.75. If I want to go from the 4.5 to the y, I could either multiply by 4/3, which is 8 over 6, or divide by 3/4. It's going to give exactly the same answer. So 4.5 times 4 over 3 is 6. 4.5 divided by 3/4 is 6. Okay, so the whole idea again would be, if you can find a scale factor, whether you write it as scale factor, whether you write it as ratio, whether you do it like I did a couple of pages back with setting up the fractions at the beginning, it's just sort of deciding whether you're multiplying or dividing by the correct scale factor. Okay then, the ones we want you to try are these ones, and these are the answers. Okay, good luck with those.